Hi guys, in this video what we're looking at is we have been given an equation of the circle and a coordinate of a point on the circle, and we're going to be asked to work out the tangent. So we're just going to go through the steps on how we actually do this. So the first thing we need to do is to find the slope of the radius, which contains a and b here. We're then going to calculate the perpendicular slope, and then we're going to use the equation of the line with the given coordinate that we've been given in the question in order to find the equation of that particular line. So let's have a look at the question. It says a large circular lake has the equation x squared plus y squared plus 2x minus 6y minus 3 is equal to 0. A rowing club has a boathouse at the point A25 on the edge of the lake. So you can see here, this is what it looks like, and this is our point 25 here, which is A. Okay, so propose to build a straight road T to pass the boathouse as a tangent to the lake. Find the equation of the road. Okay, so let's just write down x squared plus y squared plus 2x minus 6y minus 3 is equal to 0. So the first thing we need to do is we need to find the centre. Now remember, to find the centre, what we do is we look at the x value, we halve it, change the sign. We do exactly the same for the y value, halve it, change the sign. So the centre shouldn't be too difficult. Centre is going to be equal to 2x, so 2 divided by 2, which is 1, change the sign, so minus 1, minus 6 halved is minus 3, change the sign, and 3. So we can put that on our diagram now. We now know that there is minus 1 and 3. So the next thing we need to do is find the slope of that line BA here. So we want to find this slope, so then we can find the perpendicular slope of T here. So remember, the slope is given by, if you can't remember, is equal to y2 minus y1 over x2 minus x1. So I'm just going to label this x1 y1 and this one x2 y2, and just put the numbers in. So my m here is equal, or my slope is equal to y2, which is 5, minus y1, which is 3, over x2, which is 2, minus 1, which is the same as 2 plus 1 here. Okay, so we end up here with the slope being 5 minus 3, which is 2, 2 over 2 plus 1, which is 2/3. So the slope here is equal to 2/3. But we don't want that slope, we want the slope of the tangent, and we know it's at right angles. So remember, the quick rule is that in order to find the slope of the tangent, I'm going to call it mt, is equal to, all we do is we flip the fraction, 3 over 2 now, so we flip it and we change the sign. So we now have the slope of the tangent, and we now need to find out the equation of the tangent. So using the line equation, y minus y1 is equal to mx minus x1, we can now get the equation of this line. So don't forget which coordinate we're using. The coordinate we're using here is 2, 5, because 2, 5 is on the tangent, the line of the tangent here. So make sure you use 2, 5 and not minus 1, 3 here. Just going to write that on the side here. So 2, 5 is the coordinate that I want. So y minus 5 is equal to m, which is minus 3 over 2, x minus 2. And we're going to multiply everything by 2 to get rid of the fractions. We get 2y minus 10 is equal to minus 3x minus 2. I'm going to multiply out the right hand side, so we get 2y minus 10 is equal to minus 3x plus 6. Take everything across the left hand side to keep the x's positive, so we get 3x plus 2y minus 10 here, minus the other 6 is going to come across, so minus 10 minus 6 is equal to minus 16, and that there is equal to 0. So to sum up, all we have to do here is work out what the centre is, find the slope of the centre to the points that you're trying to work out if it's a tangent or work out the tangent from. Once you've got the slope, find the perpendicular slope, put it into the line equation, substitute everything in, making sure that you get the correct coordinate, so it's 2, 5 here, not the one in the circle, the centre of the circle, and then just tidy it up at the end.